This is the SOOTHSAYER ATAK plugin version 2.6. It allows you to model any RF system direct from ATAK. To use the plugin, you need to log in to your account or your server and then select a radio from the list, in this case a LoRa gateway, and click the marker to add the radio to the map. As soon as you drag a radio around, it triggers a calculation and you get to see the coverage of that system. We can repeat that to build up a network. So I'm adding a second site to the east here. I can see bi-directional links. That will be workable for this technology. And I'm going to add a third marker to the south. So there we can see we very quickly built up not just some links, but we've built up a composite heat map showing this network of free gateways very quickly within ATAK. To reduce the amount of information that we're processing and viewing on the map, we can use the polygon because the map is now starting to get cluttered. So let's use this polygon here, and what we'll do is we'll focus our effort onto the area that we care about the most, which is just around the harbour only. Now when we click the button, it will remodel this area and it will just look at the contents of this polygon. There was a rate limiting warning there. That's fine, that's because we're going quite fast, but I've repeated that, and now we can see the coverage is shown just inside the polygon only. That's what we care about. Finally, new feature added in 2.6 is best site analysis. That's the magnifying glass here. Once you've drawn a polygon, you can use this tool to calculate radio intervisibility for this polygon to show you the most efficient areas. And to prove it's not height, we've selected this area because Dartmouth is on a hill, and so Dartmouth is not such a good site to put a mast. However, the hill to the south, the water, or the hill on the other side of the river is a better place to cover this river. So this performs hundreds of calculations on a GPU and ranks them all to show you the best, and it works for different technologies. So I can use this for counter drone. I could say I want to see the most efficient site to model a counter drone system for a drone that's at 50 meters above the ground. And again, that shows me obviously the hilltops, but also in the middle of the river here, and not here around the bend, because that's a bit of a dead spot. So this is useful for LEO as well. We could select a LEO template to look at sky visibility to get the most efficient site and the most consistent performance. And so this is useful for many use cases when you're trying to select an optimal site.